Hello, welcome to 4.4. We're going to talk about the fundamental theorem of calculus today. So theorem 4.9 is the fundamental theorem of calculus. This is a big deal. It's fundamental. If a function f is continuous in the closed interval from a to b, and f is an antiderivative of little f, so capital F antiderivative of little f on the interval from a to b, then, ready for this? The ground's going to shake. The integral from a to b of f of x dx is capital F of b minus capital F of a. So we're talking about capital F being the antiderivative of little f. So when we have a definite integral, that's one where we have limits of integration, a lower and upper limit of integration. It's going to be f of b minus f of a. So when you have limits of integration, that is integrating over an interval such as ab, the integral is called a definite integral. Just mention that. This is a big deal. A little too high. I had to angle the camera, by the way, so I'm sorry if this looks a little like you're on top of a mountain, because I didn't want the lights to be bothering people. So guidelines for using the fundamental theorem of calculus. Provided you can find an antiderivative of f, you now have a way to evaluate a definite integral without having to use the limit of a sum. And when applying the fundamental theorem of calculus, the following notations are convenient. Interval from a to b of f of x dx is f of x from a to b. This is usually just a vertical line, which is f of b minus f of a. It means this is the antiderivative from a to b to f of b minus f of a. For example, the integral from 1 to 3 of x cubed dx is x to the 4th over 4 from 1 to 3. So that's going to be 3 to the 4th over 4 minus 1 to the 4th over 4, which is 81 over 4 minus 1 over 4, which is 80 over 4, which is 20. 3, it's not necessary to include a constant of integration c in the antiderivative because the constant would just subtract down. It'd be the same constant for each one because the constant is not affected by the limits, so it subtract down. Let's look at example 1. It says evaluate each definite integral. We have the integral from negative 1 to 2 of t squared minus 2. This is going to be t to the third power over 3 minus 2t. Now when I have two terms like that, I'll put brackets around the whole thing from negative 1 to 2. That's going to be 2 cubed over 3 minus 2 times 2, so I put the 2 in place of the t's, minus, I'm going to put negative 1 in place of the t's. Negative 1 cubed over 3 minus 2 times negative 1. That's going to be 8 thirds minus 4 minus the quantity that's negative 1 third minus negative makes it plus 2. So it's 8 thirds minus 4 minus negative is plus 1 third minus 2. 8 thirds plus 1 third is 9 thirds. Negative 4 minus 2 is negative 6. So it's 3 minus 6, that's negative 3. The next one's the integral from 1 to 8 of 3 times the cube root of x. So this would be like saying the integral from 1 to 8. I'll put the 3 out front, of x to the 1/3 dx. That would be 3 times what? X to the 4 thirds. If I add 1 to 1/3, I get 4 thirds. Over 4 thirds from 1 to 8. That's going to be 3 times 3/4. I'm just bringing this fraction up. Times what? 8 to the 4 thirds minus 1 to the 4 thirds. That's 9/4 times what? The cube root of 8 is 2. 2 to the 4th power is 16. And minus 1. So it's 9/4 times 15. That would work out to be 135/4, which would also be 33 3/4. And for c, we have the integral from pi over 4 to pi over 2 of cosecant squared x dx. And if you look this up in the chart, that antiderivative is going to be negative cotangent of x from pi over 4 to pi over 2. That's going to be negative of cotangent of pi over 2 minus negative cotangent of pi over 4. That's going to be 0 plus this cotangent, double negative, makes it plus 1, so you get 1. Let's go on to page 2. Okay. Example 2 says evaluate the integral. We have the integral from 0 to 3 at the absolute value of 2x minus 3. Now, recall back from your pre-calculus year, even your algebra days, that the absolute value of 2x minus 3 is equal to 2x minus 3 for x being greater than or equal to, let's see, 2x minus 3 equals 0, 2x equals 3, x equals 3 halves. So for x being greater than or equal to 3 halves. And it's the negative of 2x minus 3 for x being less than 3 halves. And this could be seen as negative 2x plus 3. So what we are really seeing here, here's 3. And here's, let's say, 3 halves. It's going to be this V shape. It's going to be coming down like that. There's a 3 there. And then we go up like that. And we're talking about the area under the curve. Now, we could solve this without calculus, but we're here. We're going to use our calculus, practice the skills that we have been developing. So I treat this as the integral from 0 to 3 of absolute value of 2x minus 3 dx. I treat that as the integral from 0 to 3 halves of the negative of 2x minus 3 plus the integral from 3 halves to 3 of 2x minus 3. We're going to have negative of what? X squared minus 3x. This is the antiderivative of 2x is x squared, and for 3 it's 3x. We're going to go from 0 to 3 halves plus x squared minus 3x from 3 halves to 3. Plug in our limits of integration. We have the negative of what? 3 halves squared minus 3 times 3 halves minus 0 squared minus 3 times 0 plus, in the second part here, 3 goes in place of the x, 3 squared minus 3 times 3 minus 3 halves squared minus 3 times 3 halves. And this should all be in parentheses there. Okay, so we have a negative 3 halves squared, that's 9/4, minus 3 times 3 halves, that's going to be minus 9/4, and so there's a negative outside this parenthesis. Shouldn't stop there. And then minus 0, because 0 squared minus 3 times 0 is 0. Then we have plus, we have 3 squared is 9, minus 3 times 3 is 9, minus what's next? We have a 9 halves minus 9 halves. Oh, there's the mistake. 3 times 3 halves is 9 halves. 3 halves squared is 9 fourths. So 9 halves minus 9 fourths. Okay, so let's kind of summarize what we have. 9 fourths minus 9 halves is the negative of negative 9 fourths plus, that's 0. Then we have the negative of negative 9 fourths. So that's going to be 9 fourths plus 9 fourths is 9 halves. And that would be this area under the curve. I'm going to go on to example 3 now. It's asking for the area of the region bounded by y equals 3x squared plus 1, bounded by x equals 0, x equals 2, and y equals 0. So in this, we're talking about a shape like this, bounded by x equals 0 to x equals 2. So this region under the curve. It's going to be the integral from 0 to 2, of 3x squared plus 1 dx. That's going to be x cubed plus x from 0 to 2. That's going to be 2 cubed plus 2 minus 0 cubed plus 0. That's again my f of 2 minus my f of 0. So we're looking at 8 plus 2 minus 0, that's 10. Okay, Theorem 410 says the mean value theorem for integrals. If f is continuous in the closed interval from a to b, then there exists a number c in the closed interval ab such that the integral from a to b of f of x dx is f of c times b minus a. Now, just to give you a little reference here, this is like the height, and this is the width or the base of a rectangle. So my point in saying this is you could have a rectangle that's going to have the same area as whatever the curve is going to be. So like this, there is a rectangle we could draw these same bases that's going to have that same area, that same base there. Okay. And move down here to definition of the average value of a function on an interval. This is the definition of an average value of the function. This is using what we just saw. If f is integrable on the closed interval from a to b, then the average value of f on the interval is 1 over b minus a times the integral from a to b of f of x dx. That gives you the average value of the interval, which happens to be what? Anyone know? F of c. Okay, example 4 says, find the values of c, guaranteed. It could, values in parentheses, I mean, it could just be 1 or it could be more. Find the values of c's guaranteed by the not man value theorem, but the mean value theorem. For the integrals for the function f of x equals 2 secant squared x over the interval from negative pi over 4 to pi over 4. So first we'll do the integral from negative pi over 4 to pi over 4 of 2 secant squared x dx. And the antiderivative of secant squared is going to be tangent, so it's going to be 2 tangent x from negative pi over 4 to pi over 4. It's 2 times tangent of pi over 4 minus tangent of negative pi over 4. That's 2 times 1 minus negative 1. 2 times 2, which is 4. So we're considering that f of c times our b minus a is 4. And our b is pi over 4, a is negative pi over 4. So f of c times pi over 4 minus negative pi over 4 equals 4. So f of c times, that's pi over 4 plus pi over 4 is 4. F of c times, that's 2 pi over 4. So f of c times, what's that going to be? Pi over 2 equals 4. That means f of c would be 4 divided by pi over 2, or f of c would be equal to 8 over pi. Now what was f? The original function here, the original function is secant squared. That means secant squared of c equals 8 over pi. That means secant of c, oh, I forgot that it's 2 secant. So if we divide the 2 out, secant squared c is 4 over pi. That means secant of c is going to be plus or minus 2 over the square root of pi, if you take the square root of both sides. So c is going to be the arc secant of 2 over the square root of pi, and c would be the arc secant, I mean, we'll do two different columns here. C equals arc secant of negative 2 over the square root of pi. So for the first one, put that in our handy dandy calculator, and arc secant of 2 over the square root of pi. If you don't have the TI-89 or that type of calculator, it's not going to have that function on it. It will have it in the TI-89. It'll say secant inverse. It'll be in the catalog. So you could say instead that's going to be arc cosine of square root of pi over 2. In which case our c is going to be 0.4817. And in the second case, c would be equal to arc secant of negative 2 over the square root of pi, which is again the same thing as arc cosine of pi over the square root of pi over negative 2. So in that case, c is negative 0.4817. So our values are c would be 0.4817 and negative 0.4817. Go on to the next one. Example 5. Let's find the average value of the function for f of x equals 4 minus x squared over the interval from negative 2 to 2, and all values of x in the interval for which the function equals its average value. So we're looking at 1 over, that's our b, that's our a. So 2 is our b, negative 2 is our a. 2 minus negative 2 times the integral from negative 2 to 2 of 4 minus x squared dx. That's 1/4. 1 over 2 minus negative 2 is 1/4 times what? The antiderivative of 4 is 4x, and the antiderivative of x squared is negative x cubed over 3 from negative 2 to 2. That's going to be 1/4 times what? 4 times 2 minus 2 cubed over 3 minus, put in the negative 2 now, 4 times negative 2 minus negative 2 cubed over 3. We're at 1/4 times what? 8 minus 8/3 minus negative 8 plus 8/3. So it's a minus in that quantity. This negative will need to be distributed. So just be aware of that when you're doing your integrals, your definite integrals. You're going to have to distribute the negative. This is 1/4 times what? 8 minus 8/3 plus 8 minus 8/3. Now if I distribute the 1/4 through to each one of these, that's going to be 2 minus 2/3 plus 2 minus 2/3. So that would be 2 plus 2 is 4, so it's 4 minus 2/3, and minus 2/3 plus 2 minus 2/3 are going to be minus 4/3. That's 12/3 minus 4/3 is 8/3. Okay, so we're looking at 4 minus x squared equals at 8/3. We want to know what x value would be. Maybe I should say it 4 minus c squared to fit more in with that f of c thing. If I subtract 4 from both sides, negative c squared equals 8/3 minus 4, which is 12/3. So negative c equals negative c squared, negative 4/3. So c equals 4/3, c squared I should say. So c would be equal to plus or minus the square root of 4/3. That means c is plus or minus 2 over the square root of 3, or c is plus or minus 2 times the square root of 3 over 3. Okay. And that'd be our exact value. You can get a decimal approximation for that. But these values will give us the average value of the function. So f of these values gives us the average value, which is 8/3. That's what this is saying. These values give us the average value of the function. So the first part was to find the average value of the function, and then to find what values give us the average value of the function. Okay, feel free to pause that. I'm going to go on. This is the definite integral as a number. The integral from a to b of f of x dx is a number. When you have numbers in here, this is a number. It's not a function. It's just a number. It works out to be a number. The definite integral is a function, however. Capital F of x is the integral from a to x of f of t dt. This gives you the function because of this x up here. Okay, example 6. Find f as a function of x and evaluate it at x equals 2, 5, and 8. So capital F of x is integral from 1 to x of 10 over v squared dv. I'd write this as integral from 1 to x of 10v to the negative 2 dv. Helps me to see it a little better. I don't get as intimidated because there's a fraction in there. So that's going to be 10v to the negative 1 over negative 1 from 1 to x. That's going to be negative 10v to the negative 1 from 1 to x. That's negative 10, and I'll do it like this now. Negative 10 over v. That's negative 10 times negative 10 over x minus negative 10 over 1. So what we have from this is negative 10 over x plus 10. Or you could say that our capital F of x would be 10 minus 10 over x. So f of 2 is 10 minus 10 over 2, which is 10 minus 5, which is 5. F of 5 is 10 minus 10 over 5, which is 10 minus 2, which is 8. And f of 8 is 10 minus 10 over 8, which is 10 minus, let's see, 10 over 8. That would be 5/4. We're looking at 4 and, no, take it back, 3 and 3/4. Something seems wrong. Not 3. No, it should be 8. There we go. I can subtract fractions in my head. See? Okay. So we took the integral and we left it with an x in there, and we plugged in numbers for the x. Now, I know that you thought that the fundamental calculus was great. It was wonderful. But it's so good that you get a bonus one here. You get the second fundamental theorem of calculus. Here it goes. If f is continuous in the open interval containing a, then for every x in the interval, the derivative with respect to x of the integral from a to t of f of t, let's just say a to x, of f of t dt would be f of x. So you get the change of the variable there. Use the fundamental theorem of calculus to find f prime of t. Okay, so in this case, f prime of, I should say, of x is going to be what? Well, as we just said, little f of x is f prime. This is just going to be x squared minus 2x. Now we can make this longer. We can first find capital F of x. And what do we get? We would have t cubed over 3 minus t squared from -1 to x, which is going to be x cubed over 3 minus x squared minus -1 cubed over 3 minus -1 squared. That's x cubed over 3 minus x squared minus, that's going to be -1/3 minus 1. So we have x cubed over 3 minus x squared plus 4/3. That's f. Now, taking that derivative then would give us 3 times x squared over 3 minus 2x, and the derivative of 4/3 is nothing. The 3's divide out, and it gives us that x squared minus 2x, what we just had above, using the second fundamental theorem of calculus. So we could take the shortcut, or we can go the long way if we want, if we're not quite comfortable with that. How about f of x here? F of x is the integral from x to x plus 2 of 4t plus 1 dt. This is going to be 4t squared over 2 plus t from x to x plus 2. That's 2t squared plus t from x to x plus 2. That's going to be 2 times x plus 2 squared plus x plus 2 minus 2x squared plus x. So we end up with 2 times the quantity x squared plus 4x plus 4 plus x plus 2 minus 2x squared minus x. So if you want to cancel that x, we can do that now. Distributing, we have 2x squared plus 8x plus 4 plus 2 minus 2x squared. And the 2x squareds go away. Now, that is f of x. So capital F of x is going to be 8x plus 6. I think I'm missing something. Oh yes, 2 times 4 is 8. So it's 8x plus 10. Now this derivative f prime of x is going to be 8. Now how could we have gotten it the other way? Well, if we would have put that 2 in place of the t, we would have had it because the x's are going to go away. So f prime of x is 8. I would not have felt comfortable doing that any other way, though. I would want to work that one out. Okay, let's go on to page 5, our last page of this section. This is the net change theorem. The definite integral of the rate of change of a quantity f prime of x gives the total change or net change in that quantity over the interval from a to b. So the integral from a to b of f prime of x dx is f of b minus f of a, the net change. So example 9 says water flows from a storage tank at a rate of 500 minus 5t liters per minute. Find the amount of water that flows out of the tank during the first 18 minutes. So we want the integral from 0 to 18 of 500 minus 5t dt. That's going to be 500t minus 5t squared over 2 from 0 to 18. That would be 500 times 18 minus 5 times 18 squared over 2 minus 500 times 0 minus 5 times 0 squared over 2. That's 9,000 minus 810, so it's 8,190 liters of water. Okay, that'll do it for this section, so send me your questions. I hope this works out well for you, and I hope you like that. Thank you. I'll see you guys later. Bye.